Hello learners, I am Dr. Hirak Dasgupta, Associate Professor, Symbiosis Institute of Management Studies, Pune. So today this video is about multiple regression. But before going to multiple regression, we will have a quick idea about simple linear regression. So we start with the simple linear regression concept. So simple linear regression is an average relationship between two variables. So one is the independent variable and the other is the dependent variable. So we are estimating the dependent variable when we have a selected value for independent variable. So the equation for simple linear regression is y is equal to a plus bx plus e. So y represents the dependent variable, x represents the independent variable, a represents the constant or the y-intercept, and b represents the slope or the change in the value of y due to the change in the value of x. E represents the error term. So let us take an example of a simple linear regression. So let us say the independent variable is the distance covered by the salesperson, and the dependent variable is the total delivery time. So after collecting the data, let us say we get the equation, regression equation, as the total delivery time is equal to 1.87 plus 0.3498 into distance covered. So now how do we interpret this equation? So if the distance covered is increased by 1 unit, then we can say the total delivery time increases by 0.3498 units or 34.98%. So now we move to multiple regression. So multiple regression and simple linear regression. So the difference between the two is, in multiple regression we have many independent variables, that is 2 or more than 2 independent variables and 1 dependent variable. So in multiple regression the equation is like y is equal to a plus b1 x1 plus b2 x2 and so on till bn xn. So where y is the dependent variable, a is the constant or the y-intercept, x1, x2, x3 to xn are the independent variables, b1, b2, b3 are the slope, and e is the error term. Now let us move to an example. Let us see an example on multiple regression. So we already have seen the dependent variable is total delivery time, and we add another independent variable, let us say called as packaging time. So let us say total delivery time is equal to a plus, let us say b1 into distance covered plus b2 into package time. So there are two slopes. The two slopes indicate the impact of these respective independent variables on the dependent variable. So similarly we can take another example. Let us say if we want to purchase a flat. So what are the independent variables for the dependent variable purchase of flat? So they can be carpet area, they can be size of the rooms, they can be number of rooms, and they can be price of the flat. So the whole equation becomes purchase of the flat is equal to a plus b1 into carpet area plus b2 into size of the rooms plus b3 into number of rooms plus b4 into price of the flat. So now how do we interpret the equation, a multiple regression equation? So let us take the example, total delivery time is equal to 1.87 plus 0.3498 distance covered plus 0.1356 into packaging time. So if we increase 1 unit of distance covered, keeping all other variables constant, then the dependent variable will increase by 0.3498 units or 34.98%. So instead of the addition sign, if it is a subtraction sign or a minus sign, so then the increase in the distance covered would lead to a decrease in the total delivery time. So this is another category of multiple regression, which is called regression with dummy variables, and it is also known as logistic regression. So dummy variables are nothing but binary variables which can take two values, 1 and 0. So let us take an example of loan amount. Let us say a banker wants to disperse a loan amount, that's a dependent variable. So what will be the criteria on which he is going to disburse the loan amount? They are all going to be the independent variables. So let us say the independent variable is age, number of years married, disposable income, and gender. So gender will become a binary variable or a dummy variable where male gets coded as 1 and female gets coded as 0. Similarly, if we take marital status, then we can code it as married and not married, married as 1 and not married as 0. So now we come to the conditions for applying multiple regression. So the first condition is that there should be a linear relationship between the dependent variable and the independent variables. The second condition should be that the variation about the predicted values should be constant, or it is also called as homoscedasticity. Third condition is that the error term should be normally distributed, and the fourth condition is there should be multicollinearity or there should not be a multicollinearity. So in this video we have seen what is simple linear regression, what is a multiple regression, what are the differences between a simple regression equation and a multiple regression equation, and what are the conditions for applying multiple regression. In the next video we will be doing it in Excel, the practical application of multiple regression. Thank you.